Okay, for what we have for sections R.8 and 1.1, in terms of getting to the solutions, now we have for question number 1, okay, it says here to write an absolute value inequality for the graph below and to use x for your variable. And if you notice, okay, we have the lower and the upper limits are -5 and 5, and we have solid points located. And now just for the general inequality, okay, now we have situated that -5 is less than or equal to x, which in turn is less than or equal to 5. And if you recall, okay, now we have among our rules, okay, we have for all values of x such that we have the absolute value of x is less than or equal to k. Then we have that -k is less than or equal to x, which in turn is less than or equal to 5. And for what we have in this particular setting, okay, if you notice, we have -k is less than or equal to x is less than or equal to 5. And if you notice, okay, we have that our k value is going to be at 5. And so translating what we have in the compound inequality in terms of an absolute value inequality, so you have in essence sort of working backwards. And so we have with k at 5, we have that the absolute value of x is less than or equal to 5. Okay, and so that will be the final answer in this particular problem. Okay. Now for what we have in the second item, it says to graph the solution to the inequality on the number line. And we have, in the case of the absolute value of w minus 3 is less than or equal to 7. And we have in this statement, we have the absolute value of w minus 3 by itself, and we have is less than or equal to 7. And now for what we have in this case, if I remove w minus 3 from the absolute value symbols, okay, now you're going to have w minus 3 is going to be between the values that have an absolute value of 7. At the lower end, we have -7, and at the upper end, we have +7. So we're going to have w minus 3 to lie between negative and +7 inclusively. So we have for the inequality that is set up, and looking at solving for w. So if I add 3 to all portions of the compound inequality, we're going to have that -4 is less than or equal to w, which in turn is going to be less than or equal to 10. And in interval terms, we have between -4 and +10 inclusively. Now, in terms of what we have for the official graph, and so we're going to have between -4 and +10 inclusively. So if I were to graph on a number line, and we have, again, -4 and 10 are included. So we have for the endpoints, -4 and +10. Okay, again, those are going to be closed. Now in the case of what we have for item number 3, we have that the absolute value of 2x minus 8 is greater than 12. And for what we have in this problem, okay, so you have the absolute value of 2x minus 8 is greater than 12. Now there are two numbers with an absolute value of 12. At the lower end we have -12, and at the upper end we have +12. Notice the direction of the inequality. So that means that for 2x minus 8, I'm increasing the distance away from 0 in a manner that we are straying more than 12 units away from 0. So we have at the lower end, okay, we have that 2x minus 8 to have this statement to end up as a value that is at a distance of more than 12 units away from 0, we're going to be looking at increasingly negative. So we're going to have 2x minus 8 is less than negative 12. And then we have at the upper end, if I'm looking at increasingly positive, I'm going to have that 2x minus 8 is greater than 12. So in looking at solving what we have for the compound, or I should say the inequalities, so if I add 8 throughout, so we're going to have 2x is less than negative 4. So we have on the one end, we have x is less than negative 2. And we have at the upper end, okay, we have that 2x is greater than 20. And with division by 2, we have that x is greater than 10. So our inequality statements are less than and greater than. So on negative 2, I'm going to have an open circle. And at 10, also an open circle, and for the directions to which we're going to have the graphs to be heading. So for x is greater than 10, have a ray that's going to the right, and for what we have in the case of x is less than negative 2, I'm going to have a ray that is going to be going out to the left. So those will be the resulting graphs of what we have for problem 3. Now, in the case of what we have in item number 4, okay, so we have 5 times the absolute value of x plus 1 followed by the addition of 8 is less than or equal to 33. And so in taking what we have now, okay, if I'm isolating the absolute value of x plus 1, so I can take away 8. And just to zoom in, okay, so we have 5 times the absolute value of x plus 1 is going to be less than or equal to 25. And if we divide by 5, we're going to have the x plus 1 is less than or equal to 5. And now for the nature of the inequality statement, again, x plus 1 is going to be situated between negative and positive 5. So we're going to have in the setup, we're going to have that negative 5 is less than or equal to x plus 1, which in turn is going to be less than or equal to 5. And getting x by itself, if I take away 1 throughout, we're going to end up with the resulting inequality statement. We're going to have that negative 6 is less than or equal to x, which in turn is going to be less than or equal to 4. And if I put this in interval notation, we're going to have brackets around negative 6 as well as 4. And so this is what we're going to have in the end result.